Now let us take the next question. A number is divisible by both 5 and 12. So we don't know the number. So that number is divisible by both 5 and 12. So by which other number will that number be always divisible? So then the first common multiple of 5 and 12, that is 60. The common first common multiple of 5 and 12 is their product. 5 into 12, 60. So then that number is always divisible by 60. Now let us take the next question. A number is divisible by 12. By what other numbers will that number be divisible? So the factors of 12 are 1 into 12, 2 into 6, 3 into 4. So the factors of 12 are 1, 2, 3, 4, 6, 12. So therefore the number is always divisible by the factors of 12 other than 12. So 1, 2, 3, 4 and 6. Now so far we have learnt the common multiples and the common factors of the given numbers. Now let us see some more divisibility rules. Now let us take the first one. If a number is divisible by another number, then it is always divisible by the factors of that number. See, for example, 60 is divisible by 12 because 12 5s are 60. Then what are the factors of 12? So the factors of 12 are 1, 2, 3, 4, 6 and also 12. So if the number 60 is divisible by 12, so then 60 is also divisible by the factors of 12, 1, 2, 3, 4 and 6 other than 12. So here 1 60s are 60, 2 30s are 60, 3 20s are 60, 4 15s are 60, 6 10s are 60. Now let us take the second rule. If a number is divisible by two co-prime numbers, then it is divisible by, then the number is divisible by their product. Let us see an example. Here 60 is divisible by two co-prime numbers 4 and 5. Here 4 and 5 have the common factor 1. So the common factor of 4 and 5 is only 1. So then 4 and 5 are the co-prime numbers. The given number 60 is divisible by 4 and 5. So then the given number is divisible by their product 4 into 5. So that is 20. Means 60 is also divisible by 20. So if a number is divisible by two co-prime numbers, then it is divisible by their product. So this is the second divisibility rule. Now let us see the third divisibility rule. So the third one is, if a number is, if two numbers are divisible by a number, then their sum is also divisible by that number. Now let us see with an example. Here 20 and 30 are divisible by 5. So 5 4s are 20, 5 6 are 30. So their sum 20 plus 30 equal to 50 is also divisible by 5, because 5 tens are 50. So if two numbers are divisible by 30, divisible by a number, the two different numbers 20 and 30 are divisible by a number 5, then their sum is also divisible by that number. So this is applicable to any two numbers. Now the next one is, if two numbers are divisible by a number, then their difference is also divisible by that number. Now if you take 30 and 20, so these both are divisible by 5. So the difference 30 minus 20 equals to 10, which is divisible by 5. So if two numbers are divisible by a number, their difference also divisible by that number. So this is also applicable to any two given numbers. Now let us see the next topic, prime factorization. Now if you take any number, then it can be expressed as the product of prime numbers. Now let us take an example, 24. So 24 can be written as the product of 2 and 12, but here 12 is not a prime number, so we write 2 into 12 can be written as 2 into 6, and here 6 is not a prime number, then we write 2 into 6 means 2 into 3. Now all the four numbers are prime numbers. So now 12 can also be written as the product of prime numbers with a tree diagram. So then we can write 24 as 3 8s are 24, 3 into 8, again 3 is the same as it is a prime number, but 8 is not a prime number, so we write 8 as the product of 2 and 4. Here 3 is a prime number, 2 is also the prime number, but 4 is not a prime number, so we write 4 as a product of 2 and 2. So finally we got 3, 2, 2, 2, all are the prime numbers. Now if we write 24 in some other way, so we can write 4 and 6, because 4 6 are 24. So but here 4 and 6 both are not prime numbers, so we can write 4 as a product of 2 and 2, and we can write 6 as a product of 2 and 3. So we got the same prime factors 2, 2, 2 and 3. Now if you take 36, so 36 can be written as 2 into 18. Again 2 is a prime number and 8 is not a prime number, so 18 can be written as 2 9s are 18, and 2 is a prime number, so we can write 9 as the product of 3 and 3. So the prime factors are 2, 2, 3 and 3. Now if you take 36 in another way, so then we can take 3 12s are 36. So 3 is a prime number, again 12 can be written as 2 6 are 12, and 2 is a prime number, 6 can be written as 2 3 are 6. So you have 3 2 2 3. So these are the prime factors of 36, and 36 can also be written as 4 9s are 36. So both 4 and 9 are not prime numbers, so we can write 4 as 2 2s are 4, 9 can be written as 3 into 3. So here 2 2 3 3 are the prime numbers. Now 36 we can write 6 6 are 36. 6 can be written as 2 into 3 and 6 can be written as 2 into 3. So here also 2 2 3 3 are the prime factors. So if any number is given, we can express it as the product of prime factors. Now let us see a few questions based on the prime factorization and also the some more divisibility rules. Now let us see the first question. Here two different factor trees for 60. So then write the missing numbers. So 60 can be factorized as 6 tens are 60, and here 6 can be factorized as 2 3s are 6. So we can write here 3, the missing number, and 10 can be written as the product of prime numbers 5 2s are 10. So 5 into 2. So the second missing number is 2. Next, in the second way, 60 can be written as 30 into 2. Then 30 can be written as 10 into 3. 10 3s are 30. And 10 can be written as 2 into 5 or 5 into 2. So the missing numbers are 2, 3, 2, 5. Now let us see the next question. Write the greatest 4-digit number and express it in terms of prime factors. So the greatest 4-digit number is 9999. So if you factorize the number 9999, so it is divisible by 3 table. So then 3 3s are 9, 3 3s are 9, 3 3s are 9, 3 3s are 9. So again it is divisible by 3 table. 3 1s are 3, 3 1s are 3, 3 1s are 3, and 3 1s are 3. So then 1111. So it is divisible by 11. So 11 ones are 11, 0, and 11 ones are 11. So as 101 is the prime number, it is not divisible by any other number. So we can write 9999 as the product of prime numbers 3 into 3 into 11 into 101.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.